Okay, so welcome to the next session from the chapter symmetry. So in the previous session, we just discussed how to find out the rotational symmetry for square, which is one of the common regular polygons. Now in this session, we'll try to look at the method for finding the rotational symmetry in a bit more detail, because I think it's a bit more complicated and it isn't straightforward to find out the rotational symmetry, and it's a bit confusing. So it is worthwhile for us to have a closer look at the methods. So now let's go through the steps one by one. So so this was what we did in our previous session. We found out that the order of rotational symmetry for a square is 4. Now let's move on to the next part, in which we are discussing the details. Okay, so the first step that we did was to identify the center of rotation, and typically it would be the center of the object. So in our previous example, what we had was a square. I mean, it is not going to be a perfect square here because of the way I am drawing it, but yeah, imagine it's square and we take the center of the square to be the center of rotation. So that is the first thing that we need to do. Find out the center of rotation. Second thing, identify the angle of rotation. Now I did mention that we rotated the angle by 90 degree, but why 90 degree was selected, we did not discuss in detail about that. So now first let me define more clearly what do we mean by identifying the angle of rotation, or what is the angle of rotation. So the angle of rotation is the minimum angle by which, if we rotate the object, it still looks the same. Now look, this is very important, this minimum angle. It's extremely important to note the minimum angle. The reason why we said 90 degree is because 90 degree is the minimum angle. Sorry for these lines going in a bit different direction, but you get the sense of it, right? So the minimum angle by which I rotate the square and it still looks the same is 90 degrees. Now imagine if I rotate the square by 180 degrees, it will still look the same, right? Not only that, let's say that this is a point P. If I'm rotating it by 180 degree, so it means I go from here to here and from here to here, and then this point it will travel from here to here, and with one more 180 degree rotation, that is 2 rotations here, the P point comes here. So if you choose your angle of rotation as 180 degree, right, the order of rotational symmetry will come out to be 2. If you are selecting the angle of rotation to be 90 degree, the order of rotational symmetry will come out to be 4. Now what is the other angle through which I rotate and still I get the same type of object? See, the other criteria for is to select 360 degree, that is give one complete turn. So I just give a complete turn to the square from here to here and still it will look the same. So if I use this angle of rotation to be 360 degree, then the order of symmetry becomes 1. So now you understand why minimum angle. We have to find out the minimum angle by which we rotate. So in this case it is the 90 degree. See, if you can try taking any other angle, let's say 45 degree. If you take it, then how will this go? If you just start rotating at 45 degree, this corner will come somewhere here and you get some figure like this, just something like this. Yeah, so this is not looking as the earlier object. So that is why we call that it has to be the minimum angle. Keep this thing in mind. Then we identify the rotation, the direction of rotation. Now it could be either clockwise or anti-clockwise. Again, you can just select any one of them, and it's a matter of personal choice, but generally it will be good to take a clockwise. This is just as a matter of convention. So in our previous example, we took the clockwise, that is the square was rotating in this direction, which is the clockwise. This one is clockwise. We could also have taken an anti-clockwise, which is the opposite direction, that is we could have rotated it in this way. Okay, so this would have become an anti-clockwise direction. So again, it's a matter of preference and you can select whatever you like. So this is the third step. Once you have identified the angle of rotation, You identify a point or corner on the object to follow during rotations and give the object a complete turn in steps of angle of rotation. This is extremely important. That is, you have to give a complete turn to the object in steps of angle of. So in our earlier example of when we were finding the rotational symmetry for a square, we gave a complete turn to the square in steps of 90 degrees and followed the point P as we did in our earlier example. Okay, so that's why we say that give a complete turn. When I say complete turn, it means that whatever the point which we are following, right, the point on the object which we are following, it should come back to its original position. That's why we say it's complete turn. Okay, and this is essentially what you need to do. And now having discussed these 4 steps, that is, first we identify the center of rotation, identify the angle of rotation, which is the minimum angle by which we rotate the object, it still looks the same, identify the direction of rotation, identify a point or corner on the object to follow, and give it a complete turn in steps of angle of rotation. Okay, and just see and try to find out the symmetry for equilateral triangle, regular pentagon, and regular hexagon. It's a worthwhile exercise to try out. Now, I would just like to give you a few quick examples or a few quick observations for rotational symmetry. So, before that, let us now formally define what is order of rotational symmetry. So, in a complete turn, that is 360 degrees, the number of times the object looks exactly the same is called the order of rotational symmetry. It's important to keep in mind in a complete turn, that is 360 degrees. But you have to keep in mind when I say complete turn, it is not a complete turn in one complete turn straight away. It is a complete turn in steps of angle of rotation. This is something that you need to keep in mind, in steps of angle of rotation. Okay, it looks exactly, and the number of times the objects looks exactly the same is called the order of rotational symmetry. So a pretty much straightforward way to have a look at is, for example, if you say that your angle of rotation is 90 degree, okay, and so you rotate the object 4 times, so it has to be rotated 4 times, and it is equal to 360 degrees. So it completes, when I rotate an object 4 times in steps of 90 degrees, it will complete 360 degree rotation. And we see that for each of these rotations the object looks same. Then this number 4, right, it is the order of rotational symmetry for the particular object. Okay, so the second one is now the observations of rotational symmetry for regular polygons. Now just some general observations. See, the first thing, in general, the center of rotation would be the center of the regular polygon. So if you're taking an equilateral triangle, a regular hexagon, or a regular pentagon, the center of that regular polygon will be the center of rotation. The angle of rotation, an important thing to keep in mind. How to identify? It simply equals to the angle of regular polygon. For example, in an equilateral triangle, if you remember, the angle between two sides is 60 degrees. So you can take the angle of rotation to be 60 degrees. And similarly, for a hexagon, it will be 120 degrees. Or can you think of any other angle? Just try thinking. And a good thing to try out here would be to take a piece of paper and just put something in the center so that it doesn't move, and then try rotating it in different angles and see. It's the same thing that we tried for finding the line symmetry. Okay, and important thing to keep in mind is that the order of rotational symmetry equals to the number of angles, number of equal angles. This is very important to know, equal angles. So if I say that the order of rotational symmetry for a triangle, it will be 3. For triangle it is 3. For a pentagon it should be 5. And for a hexagon it should be 6, because it has 6 equal number of angles. If you just try it out with a piece of paper and see whether all these things hold true or not. Now it is important to know that every object will have a rotational symmetry of order 1. If you cannot find out any angle through which you rotate an object and doesn't look same, by default you rotate by 360 degree and it will still look the same. So that is what the main thing is. So in the worst case, an object which doesn't exhibit any type of symmetry, it will still have a rotational symmetry of order 1. And that is the reason is because it comes to the same position after giving it one full turn of 360 degrees. So having said that, we have completed our discussion on rotational symmetry, and see you soon in the next session, in which we continue our discussion on objects having both line and rotational symmetry.